Assalamualaikum warahmatullahi wabarakatuh. Okay, for this video, I will be showing you an example on heat equation. The question is actually a past year question, which copyright all belongs to UiTM. Okay, so right now the question here is consider the conduction of heat along a rod of length 1 centimeter. Okay, from here we know that it is a heat equation because it is for heat along a rod. Okay, and the length is 1 centimeter, which means L is equal to 1, and it satisfies the heat equation, this one, 9USX equal to UT, and we need to find the temperature distribution of UST along the rod if both ends of the rod are kept at 0 degrees C, which means here is case A. Case A. For all time t greater than 0 and the initial condition is as such. Okay, that means it is a piecewise function. Okay, it is us not equal to x plus 1 when x between 0 to 0.5 and 0 when x between 0.5 to 1. Okay, so right now, the first step is to let ust is equal to x of x times t of t. Okay, uxx is equal to x double prime x t of t, and ut is equal to x of x t prime t. This is the partial derivative for u. Okay, that means for usx we differentiate u with respect to x twice, so t will remain as constant, and for ut we differentiate u with respect to t, and x function of x will be constant. Okay, next substitute usx and ut here in the given PDE, this one, 9usx equal to ut, and hence we use method of separable where we separate the unknowns x with x and t with t. So here we have x double prime x over x of x equal to t prime t over 9 t of t equal to negative lambda squared. Okay, we will use the separation constant as negative lambda squared because this actually satisfies all the boundary conditions for heat equation. Okay, so remember the constant should be with function of t. Okay, so next we separate the variables and we need to find what is the function for x and t. So here x double prime x is equal to negative lambda squared x, where we have this equation then. Okay, and using auxiliary equations or characteristic equations, okay, we have m squared plus lambda squared equal to 0, where m is equal to plus minus lambda I. Therefore, s of x is equal to a1 cos lambda x plus a2 sin lambda x. Okay, and here for t, function of t, we have t prime t over 9t of t equal to negative lambda squared, where it can be simplified into this equation here. And then using auxiliary equations again, we will have m plus 9 lambda squared equal to 0, where m is equal to negative 9 lambda squared. Okay, therefore t of t is equal to b exponent negative 9 lambda squared t. Okay, and here thus ust is equal to, remember, x of x times t of t, we actually rewrite this, multiply with this one. Okay, and let's apply the first condition where u0t should be equal to 0, and therefore s0t of t is equal to 0 because here is the value for x. Okay, and then t of t does not equal to 0, so therefore s0 is equal to 0 then. Okay, so next you just need to substitute 0, the value 0 here in s of x, where it will be a1 cos 0 plus a2 sin 0. Okay, and here sin 0 is equal to 0 and cos 0 is equal to 1. Okay, that's why we have a1 equal to 0, and therefore x of x will be equal to a2 sin lambda x only. Okay, and next, okay, we need to apply the second condition, which is u1 t equal to 0 because ULT equal to 0. So L is equal to 1. So here U1t equal to 0, which means x1 t of t equal to 0. Since t of t does not equal to 0, therefore x1 equal to 0. Okay, we just substitute 1 in the equation earlier, which is the one that we have gotten from the first condition, x of x equal to a2 sine lambda x. So substitute 1 here. So we have a2 sine lambda equal to 0. Okay. So a2 does not equal to 0 because if a2 equal to 0, it will be trivial solution. We won't have any solution then. Okay. So a2 cannot be, a2 does not equal to 0 and therefore sine lambda equal to 0. Okay. Remember, sine n pi is equal to 0. Therefore, here we have sine lambda equal to sine n pi. Okay. We compare the angle. So, here lambda is equal to n pi. Okay. Oh, I did rewrite it twice. Sorry. So, here lambda equal to n pi for n equal to 1, 2, 3 until infinite. Okay. So, s of n would be a to n. Okay, sine n pi x and Tn is equal to b of n, exponent 9n squared pi squared t because lambda squared, remember? Okay, this one is for n equal to 1, 2, 3 until infinite. So here you just need to substitute the value lambda that we have gotten here. Okay. Next, thus unxt is equal to an sine n pi x, okay, because xn times tn, exponent negative 9 n squared pi squared t, where an here, this one, is actually a to n times b of n, okay, for n equal to 1, 2, 3 until infinite. Okay, next, we use the superposition principle, and therefore uxt will be summation of n from 1 to infinity, and just rewrite everything here. Okay, that means an sine n pi x exponent negative 9 n squared pi squared t. Okay, that means we use the superposition principle so that we don't have to write for n equal to 1, 2, 3 over and over again. We just substitute it with summation. Okay, and the third condition, which is the last one. Okay, us naught is equal to x plus 1 when x between 0 to half and 0 when x between half to 1. Okay. So here ux0 means, which means here we need to substitute t equal to 0. And hence we have here summation n from 1 to infinity a of n sine n pi x. Okay. Substitute 0 here in t. So we have exponent 0 equal to fx. Remember, exponent 0 is equal to 1. Anything power to 0 would be equal to 1. Okay. So we have this equation then, which means here this is Fourier sine series. Okay. And then an can be obtained by using this formula. Remember, for Fourier sine series, we have fx equal to summation n from 1 to infinity bn sine n pi x over L. Okay. Where bn is equal to 2 over L, integrate 0 to L, fx sine n pi x over L with respect to x. So we did the same here. Okay, I did the same here. So 2 over 1 because L is equal to 1. Okay, since this is a piecewise function, so we need to separate them. So from 0 to half, it will be x plus 1 times sine n pi x, integrate with respect to x. And plus, integrate from half to 1, the function is 0, multiply with sine n pi x with respect to x. Remember, this is compulsory to write, okay, with respect to. Okay, because when we integrate, that means we need to integrate with respect to something, right? So remember to write that. And even though this is 0, remember, please write it first, 0 times sine n pi x over L. Okay. And from here, this one is equal to 0 because integrating definite function for 0 would be 0. Okay. And it will be an is equal to 2 integrate from 0 to half x plus 1 times x sine n pi x with respect to x. Since we need to do integration by parts, so we do a tabular integration because it will be simpler for us. Okay, so here we let u equal to the algebraic function, which is x plus 1. So on this part, for this part, you need to differentiate, and for dv, you need to integrate. So x plus 1, differentiate until you get 0, and for dv is sine n pi x, so you need to integrate to obtain the v. Okay, so integrate sine n pi x is negative 1 over n pi cos n pi x, and integrating this function, we have this one. Okay, next, remember, you need to add the diagonal line, plus minus, it is an alternate, so let's say we have another row, then it will be plus minus plus. Okay, so an is equal to 2, because here is 2, times, okay, open the bracket, positive, positive, negative, therefore, negative x plus 1 over n pi. Remember, x plus 1 should be written in bracket starting from here. Okay, okay, it should be written in bracket because it is one function as itself. Okay, x plus 1 over negative x plus 1 over n pi, cos n pi x, positive, negative, negative will be positive. Positive 1 over n squared pi squared sin n pi x, substitute from 0 to half. Okay, remember, show your substitution. That means substitute the upper boundary minus the lower boundary. So right now, cos 0 is equal to 1 and sin 0 is equal to 0. And therefore, we are left with this. Simplify, and this will be your an then. Okay, so next, rewrite the final answer, which is ust is equal to summation and from 1 to infinity. Okay, everything for an, okay, the whole coefficient for an should be written in bracket. Okay, multiply with sin n pi x, exponent negative 9 n squared pi squared t. Okay, that's it for this example. Okay, hopefully you understand and grasp the understanding on how to solve heat equation for case A. Thank you everyone. Assalamualaikum.